Hi everybody, this is a video tutorial on how to use Rguroo to complete a hypothesis test. So I'm going to go and look at a previous example that we have already worked in a previous video that you most likely have in your notes. It is example 1, Facebook time. It says a study by the web metrics firm Hitwise showed that in August 2008, the mean time spent per visit to Facebook was 19.5 minutes. Assume the standard deviation of the population is 8 minutes. Suppose that a simple random sample of 100 visits in August 2009 has a sample mean of 21.5 minutes. A social scientist is interested in knowing whether the mean time of Facebook visits has increased. Conduct a hypothesis test to determine this. Use a significance level of 0.05. So you can see we already completed the hypothesis test. We saw that the social scientist was interested in knowing whether the mean Facebook time had increased from 19.5. So from that, we had written our null and our alternate statements, as you can see. On the right-hand side, you can see we chose to do a z-test because they had given us the population standard deviation rather than the sample standard deviation, and we were testing a mean. And we found the p-value of 0.0062. So just to remind you, the p-value is the probability that if the null was true, if the mean time of Facebook visits really was 19.5, that if you were to take a sample of 100 Facebook visits, that you would get a sample mean as extreme as we did, specifically 21.5, if the true mean really were 19.5. So that was a very small probability, 0.0062, which meant it was very unlikely to happen. And so because of that, we said, well, we should reject the null because that's a very low probability of happening. It's very unlikely, yet it did happen. And so because it happened, there must be another reason, and that reason being that most likely our assumption, the null, isn't true. So then we were able to reject the null and conclude that the mean time of Facebook visits really had increased. So we're going to do the same exact problem, same exact statistics, everything, but instead of using a TI calculator, we are going to use Rguroo. So again, the null is that the mean is equal to 19.5. Alternate is that it's greater. The population standard deviation is 8, sample mean of 21.5, n equals 100. So let's go to Rguroo, and hypothesis tests are under analytics, and if you click on analysis, you will click on mean inference because we're testing a hypothesis test for a mean, and we're going to do one population. This should look familiar because this is the same box we use for confidence intervals. So you do not have to do this, but you can calculate a you can calculate a confidence interval to estimate the mean of the population at the same time as you are performing a hypothesis test on the mean of a population. At the top, it says data set. So if you were testing a data set that you already have in Rguroo, like you might do for a project, you would click on the data set and choose the variable you're testing. We're not doing that. We're entering our own stats. So the sample mean was 21.5, and they gave us the population standard deviation of 8. They did not give us the sample standard deviation. It was the population standard deviation. Sample size was 100. And if you'll recall, when we did confidence intervals, you have to label what you are finding the mean of. So in this case, it's the mean the mean time of Facebook visits. That's what it is. And so if we were doing a confidence interval, you would choose the confidence level. I'm just going to keep it at 0.95 since I don't have to do that. I'm just doing it as something extra. And then I would use a Z statistic. So again, you can just leave all of that blank if you do not want a confidence interval. Or if you are interested in having it, you would just click on the type of method and the confidence level. And then when you're ready to do the hypothesis test, you would click on the hypothesis test tab, put in your significance level, which is 0.05. And then the alternative hypothesis was that it was greater than, so do the drop down, choose greater than, and then 19.5. And then before you can run the test, you need to choose the method. We've not learned bootstrap methods, so it's either going to be T statistic or Z statistic. If they gave you the sample standard deviation, you would choose T statistic. If they give you the population standard deviation, you will choose Z statistic. So I will choose Z statistic, and then I will choose my preview button. And you'll see they give us a lot of information. At the top, they give you the data summary. You just look over that and make sure that agrees with what you had entered. Next, if you did the confidence interval, that will pop up next so that we can see our lower boundary is 19.932 and our upper boundary is 23.068. So the true population mean time of Facebook visits is somewhere between 19.93 and 23.07, which is above 19.5. So this is saying that it is above. But really what we're here for is our hypothesis test. So you'll see that at the top they have the alternate hypothesis statement written in words. The mean of time of Facebook visits is greater than 19.5. That is what we have for our alternate statement. We just had it written as in symbolic form. If you look at the table, they give you sample mean, they give you standard error, they give you observed z-stat. That's if you had changed your sample mean to a z-score. They also give us a critical, they give us a critical value based off of our significance level. That's very similar to when we did critical values for confidence levels with confidence intervals. But we want to skip all that and look at the p-value and check out the p-value, 0.0062. That's exactly what we had gotten before, 0.0062. And they also give us a nice visual of the p-value. So they give us it in two different versions. One on a regular scale, and another if they had converted everything to z-scores. That's the standard normal scale. Either way, the sample mean is represented by the green triangle at the bottom of each of those graphs, and you can see where it is on the graph, and you can see the red shaded probability to the right of that. And you can see that's a very small probability. That's a small shaded region. So they're giving us a visual, so we can actually see the probability is small, small enough to make the test significant at the 5% level, meaning we're going to reject the null and accept the alternate hypothesis. So it's the same exact thing that we got here. It's just using Rguroo instead of using a TI calculator. Now, the great thing about this is you can copy the images, you can copy the tables, you can use that if you are doing a project. So you would just, in this case, I might save image as or copy image for these little graphs down here. If I wanted to copy one of the tables, I'd probably highlight it and then right click and do copy and then paste it into whatever document I would be using for a project. So that is basically it for testing a mean. All right, and so again, if you wanted to use a data set that's you already have, you would just click on the data set, and then, so like let's say I did cereal, and then you would choose the variable that you were interested in. So let's say I was interested in calories, and then it fills in all the info that you need from there. All right, so real quick, I want to do one more. I'm not going to do a T test because it's the same as the Z test. It's just they give us the sample standard deviation instead, and so you would just make sure you choose T statistic. But I did want to do, let's see. Let's do this one. Job satisfaction. This was a proportion test, so we did a 1-prop-Z test in the calculator. It says a nationwide survey of working adults indicates that only 50% of them are satisfied with their jobs. The president of a large company believes that more than 50% of employees at his company are satisfied with their jobs. To test his belief, he surveys a random sample of 100 employees, and 54 of them report that they are satisfied with their jobs. Can he conclude that more than 50% of employees at the company are satisfied with their jobs? Use a 0.05 level of significance. And we got a p-value of 0.2119. You can see where we wrote the null in the alternate statement. So for this one, because you're not testing a mean, you're testing a proportion, when you click on analysis drop down for analytics, you're going to choose proportion inference, one population. Again, if you were going to select a data set, you would select that here, but we're not. Our sample size was 100 employees. So you not only type in 100 for the sample size, you need to label it. So 100 employees, a success. It says 54 of them report that they are satisfied with their jobs. So next to number of successes, I'm going to say 54 are satisfied with job. And that means our failure is that they are not satisfied with job. You don't have to put in the failure unless you want to. And just like before, you can choose to do a confidence interval. So you would type in a confidence level if you wanted, and then click large sample Z. Over on the hypothesis test side, we're going to say that it is, what do we say, greater than 50%? Because he thought it was more. So greater than 0.50 or 0.5, and then you're going to choose large sample Z, and then you would type in your significance level, which is 0.05 again, and then preview. And then at the top, you'll see we've got a data table with the number satisfied with their job, the number not satisfied with their job, along with percentages. And then we have the confidence level. Confidence interval if we wanted that. And we can see that the percent satisfied with their jobs is between 44% and 64%. 50% is within that range. So the confidence interval, if we just looked at that, that is showing that it's not greater than 50%, because the entire confidence level is not greater than 50%. 50% is in between the lower and the upper value. But again, what we're interested in here is our hypothesis test. So you can see they give you a lot of the same statistics, but we want this one, the p-value. So if you look at the p-value, you see it's 0.211855. If you look back over here, we got 0.2119. That would round to 0.2119. And so that is a larger probability. That probability, that p-value is not less than 0.05. It's much greater. You can see, and you can even see it. Like, look at the shading. So these green triangles represent our sample proportion, which, by the way, our sample proportion was 54%. And 54% in this case has a probability of 0.21186 of occurring. You can see it's a pretty large probability. So that's not enough information to reject the null. So since we can't reject the null, we fail to reject it. So there's not enough evidence to support the alternate that is greater than 50. And if you look here, right above where it says p-value graph, it says test is not significant at the 5% level, which means you would fail to reject the null. Okay, so that's basically it. And again, if you wanted to do your own data set, you would just click data set, choose it, and then you would have to choose the variables, and then all of the other stuff would just populate on its own. So anytime you do one of these one population proportion inferences, whether it's a confidence interval or a test, you're going to choose large sample Z. Okay, so that is all. If you have questions on using Rguroo for this, let me know.